In this video, we are going to see the answer for CrNH3 6 times 3 plus is paramagnetic, while NaCN4 2- is diamagnetic. Explain why. Here, I have explained according to VB theory, that is valence bond theory, why CrNH3 6 times 3 plus is paramagnetic, while NaCN4 times 2- is diamagnetic. Here you can see the answer. First, we consider this complex CrNH3 6 times 3 plus. Next, we have to calculate oxidation state of chromium in this complex. For this, we have to take this complex like this: chromium plus 6 NH3 is equal to plus 3. Oxidation state of ammonium is equal to 0. Substituting this value in this equation, we get oxidation state of chromium is plus 3. The name of the complex is hexamine chromium 3. In periodic table, the atomic number of chromium is 24. So its electronic configuration, that is valence electronic configuration, is organ 4s1 3d5. The valence electrons are filled in these orbitals according to Pauli's exclusion principle and the Hund's rule multiplicity. But in this complex, chromium exists as plus 3 oxidation state, so we have to remove 3 valence electrons from these orbitals. So in plus 3 state, the electronic configuration of chromium is arg 3d3. So in this chromium complex, chromium has these valence orbitals, that is 3d, 4s, 4p and 4d orbitals. 3 electrons are filled in 3d orbitals. In this complex, 6 ammonium ligands are present. These ammonium ligands are strong ligands. So it needs 6 vacant orbitals to form 6 coordinate bonds. So chromium 3 plus is the central metal ion. This central metal ion of valence orbital, 6 valence orbital, that is 3d, 2 3d orbitals, 1 4s and 3 4p orbitals hybridized together, forming d2sp3 hybridized orbitals. So in this hybridized orbital, 6 ammonium ligands, each donating one lone pair of electrons to the empty d2sp3 hybridized orbitals, forming 6 coordinate bonds. Here you can see the d2sp3 hybridized orbital of CrNH3 6 times 3 plus. Geometry is octahedral geometry. Hybridization is d2sp3. Chromium is occupied at the center of this geometry. 6 ammonium ligands are occupied at the corners of the hybridized orbital of d2sp3. Each ammonium ligand donating one lone pair of electrons to the central metal ion, that is chromium 3 plus ion, forming 6 coordinate bond to the central metal ion, that is chromium 3 plus. Here this complex is inner orbital complex. Hybridization is d2sp3 hybridization. In this complex it has 3 unpaired electrons, so it is paramagnetic in nature. Next we consider this complex, that is the nickel CN4 times 2-. Here we have to calculate oxidation state of nickel. For this we take this complex like this. Oxidation state of cyanide is -1. Substituting this value in this equation, we get +2. So oxidation state of nickel in this complex is +2. The name of the complex is tetracyanidonickelate 2. In periodic table, the atomic number of nickel is 28. Its electronic configuration is argon 3d8 4s2. Electrons are filled in this orbital according to Pauli's exclusion principle and Hund's rule spin multiplicity. In this complex, nickel exists as +2 oxidation state. So it has to remove 2 electrons from 4s orbital. So new electronic configuration in +2 state is argon 3d8. This is the nickel 2 plus valence electronic configuration. In this complex, four cyanide ligands are present. These four cyanide ligands are strong field ligands, so it can do pairing of electrons in d orbital. Here you can see how electrons are pairing in d orbitals. Now one 3d orbital and one 4s orbital and two 4p orbitals hybridized together forming dsp2 hybridized orbitals. That is four dsp2 hybridized orbitals. These four cyanide ligands are donating four lone pair of electrons to the four dsp2 hybridized orbitals forming four coordinate bonds to the nickel 2 plus ion. So after formation of coordinate bond, no unpaired electrons are available. So this complex is diamagnetic in nature. Here you can see the dsp2 hybridized orbitals of this nickel complex. The structure is square planar. This complex is diamagnetic in nature due to absence of unpaired electrons.